So we did a few problems on Monday that resulted in answers that had negative powers, and we left them like that. And typically we don't do that. And what we're going to do today is talk a little bit more about what negative powers are and what they mean. And we alluded to it a little bit when we were talking about the rules for polynomials. But we're going to really get into it today, and you're going to get plenty of practice on it today, because I want you to get good at it. So the thing you need to know is that negative exponents have nothing to do with negative numbers. You think, how can that even be possible? It's clearly a negative number. And I mean it in this way. When we think of negative numbers, we think about, on the left side of a number line, or, the opposite sign, or negative times a positive, negative, that kind of thing. A negative power has a whole kind of different meaning. And what we do with it and how it operates is a little different than what you're used to, okay? They actually have to do more with where they sit, their placement with respect to a fraction bar. And we're going to look at some examples so you know exactly what I mean. Let me bring these answers back. These are the answers that we had to the first set of problems that I introduced to you on Monday. Okay? And if you remember, we got a bunch of negative powers for answers. Yeah, did I give you these?
Yeah. I don't.
So, these were the answers, and we left them like this on Monday. And the reason why we left them like this, we used our power rules, and we added, subtracted, whatever, and we got these answers. Typically, we don't leave them as negative powers. If you move a term across a fraction bar, the sign of the power is going to change. And in this case, we have 3 different negative powers. And typically speaking, we don't want to leave them. We want to get rid of those negative powers. And to do that, all we have to do is what's down there in green. Okay? Now, for A, you're looking at this problem, you're like, fraction bar? What fraction bar? There's no fraction bar. Okay? Whenever we have a number, we can turn it into a fraction, right? How do I turn any number into a fraction? Like if I had the number 5 and I needed to write 5 as a fraction, I would just put a 1 under it, right? I can do that with any number, just like I could here. So what we're going to do, for starters, is I'm going to put a fraction bar here. Now I would normally write a 1 down here to indicate that I have a fraction. Okay. But my problem is, my issue is, my concern is this right here. I have this x to the negative 4, and I want it to be positive 4. But you can't just make it a positive 4. The way that you make it a positive 4 is you just move it across the fraction bar, and then what will happen is it becomes positive. Okay, now I could have that 1 as well, but 1 times x to the 4th and x to the 4th are the same thing. Okay, so now I've gotten rid of the negative power, but now I have a blank numerator. Right, so what goes up on top there? Is it a 0? Is it blank, empty, 0? No, it's a 1, right? Because what if it was a 0, what would the whole thing equal? 0. So I have to have 1 as a placeholder. So in reality, x to the negative 4th just equals 1 over x to the 4th. And moving across the fraction bar in either direction changes the sign of the power. Okay? So if it was in the denominator and it had a negative power, I just have to move it up and it would change to a positive power. Okay? Question. Okay, so thinking about it in terms of polynomials, yes, a is not a polynomial for 2 reasons. 1, it's raised to a negative power. And now we know when you raise a number to a negative power, what that really means is you have that variable in a denominator like I showed here. So if you remember on Monday I had 2 parts. It says no variables in denominators, and then underneath that I said, which means they can't be raised to negative powers. Because in reality is, when I raise a variable to a negative power, that means the variable is in the denominator. Okay? Now the same thing works with b. even though it's a variable, okay? Or sorry, it's a it's a number, not a variable. Right? So I've got a fraction bar. I take the 3 to the negative 2, the whole thing, just the part that's raised to the negative power, and I slide it down. And that makes it 1 over 3 squared. Well, what is 3 squared? We can simplify it. Right. So this is actually 1 over 9. And whenever you have just numbers raised to powers, unless it's some ridiculous power and some crazy number, you should simplify it. Okay?
So doesn't it change the sign of the number?
Does not change the sign of the whole number. And so that's the part where I'm talking about, where I say negative powers have nothing to do with negative numbers. Because you feel like that negative power should somehow affect the base in a negative way, right? Negative 9, negative 3, something like that. It has nothing to do with that. Okay? Now, I want to talk about this problem a little bit more before I go on to C. Because if you remember, maybe you don't, but the original problem for this was 3 to the third over 3 to the fifth. So if, when we did this problem, we said, okay, when you divide and the bases are the same, you subtract the power. So that's why we got 3 minus 5, and that became negative 2. But in reality, this is 3 times 3 times 3, that's 3 to the third, over 3 times 3 times 3 times 3 times 3, that's 3 to the fifth. And if I cancel 3 of the 3's, I'm left with that. Okay? So another way of sort of demonstrating that negative power, when we move it down, that it kind of makes sense. That it works. Okay? Now, let's look at C real quick. We have a fraction bar already. Okay? I've got this x to the negative 3. With respect to the fraction bar, because it's off to the side, right? If I were to put it all together, where would the x to the negative 3 be? Would it be on top or would it be on bottom? Okay, so let's think about it. Let's think about it without the power. Actually, I'll just give a whole different example. If I had 1/4 y, does this equal y over 4? Or does it equal 1 over 4y? I need a vote. Vote for y over 4, raise your hand. Vote for 1 over 4y, raise your hand. Okay? So let's explain why. Which one it is. If I was to make y as a fraction, what would it be? 1 over y or y over 1? Y over 1. When you multiply, because these are multiplied, multiply across the top, multiply across the bottom, this is y over 4. Okay, so you guys most of you were right. A couple of you had a little issue there. So, in reality, my point is that this x to the negative 3 is on top of a fraction bar right now. That's where it would be. Okay? So in order to get rid of it, the negative power, that is, what I'm going to do is move it down. Well, that means it's going to be with the 3 now. Okay, so I have 1 over 3x to the third. And that's now simplified without negative powers. You only move the part that has the negative power. If it doesn't have a negative power attached to it, leave it alone. And we're going to look at some examples here in a second where you're going to be unsure which ones to move and what not to move. Okay. Here's some examples. Oh, wait, no more explanations. And I've said this already, but now write it down, so let's get it in your notes so you're clear. When you see a negative exponent, you want to turn it positive. Okay? That should be your goal. There's a couple situations where you might keep a negative power, but that's going to be rare, and when we get to something like that, I'll explain it. But generally speaking, get rid of negative powers. And again, the goal, the way that we do that is just to move that negative power across the fraction bar. In either direction. Like I said, If it's down below in the denominator and it's a negative power, then you got to move it up. If it's in the numerator, like the other examples that we just did, and it's raised to a negative power, then we just want to move it down. Okay? And then that sign of the power changes. So here's some examples, okay, where each of the problems has negative powers in it. And your goal here is to only simplify it as far as you can, so that there are no longer negative powers, okay? And in all three of these problems, we've got some numbers raised to powers, so and none of them are that crazy. So go ahead and simplify those down as well too, okay? Take a few minutes to work through that, and then we'll go over them. So those are both right. 1 over 7 squared is where we start, right? This goes down. And so this is 1 over 7 squared. That's simple enough, right? We can do that. In fact, you don't need a calculator to do 7 times 7 in your head, I hope. Okay, so that is 1 over 49. So yeah, simplify as far as you can. Like I said, if the numbers get crazy, if this said 7 to the 10th, like I don't care what that number is. It's a giant number. 7 to the 3rd, 7 to the 4th, 4th, 5th powers, you can do that. All right? Now, if it's 72 to the 5th power, that's a different thing. If you're not sure, okay, my advice to you is just ask me. I'll tell you, okay? But generally speaking, change them into a simplified number, okay? B, I was trying to trick you a little bit, and I hope I tricked some of you, because that's, the best way to learn stuff, by making mistakes. Okay. So this 4 to the negative 3, it's got to go where? Down. What else has to move? 5 to the negative 2 has to go where? Up. What about the x to the 7th? Very good. Yeah, there's nothing wrong with it. It's got a positive power. There's no reason to mess with it. Okay? So we don't need to. So here's what I end up with. We always put the numbers in front. So I have 5 now to the positive 2, x to the 7th, and then 4 to the positive 3. Now both of those I think we can simplify. Those are easy enough to do. The x to the 7th stays put. So what's 5 to the 2nd? 25. X to the 7th. 4 to the 3rd? 64. How many had that for your answer? Good job. All right. Last one. What has to happen here?
Make 2 to the 4th go up.
2 to the 4th to the negative 4, make it go up. Then what's on the bottom? 1.
16.
Okay, so I can write the 1, but I don't need to.
Yeah.
Right? So 2 to the 4th is 16. That is correct. How many had that one right? Right, good. Let's look at another example. Are there any questions? Ish. 3 more. Try those. So I have 2 options on the first one. I could get rid of the negative power first, and some of you did that. Or, when you multiply exponents and the base is the same, what do you do with the powers? Add them. That's how I would do this. So what's negative 7 plus 4? Okay. And so then I have a negative power, which we need to get rid of, so it becomes 1 over x to the 3rd. Okay? That's my final answer. Now, again, if you would have moved this down right away and had 1 over x to the 7th times x to the 4th, that would also be fine. Okay? But you still have x to the 4th over x to the 7th, which leads me back to that. Okay? 4 minus 7 is negative 3. So I would save the steps personally. Okay? For me, and hopefully for you, I think you feel this way, you want to do as little work possible.
Yes.
Right? I want to knock this out and get it done. So let's try to do that. How many did have that? 1 over x to the 3rd. Good.
No, I had 1 over x to the 3rd. Oh, yeah. Let's see. Never mind. Sorry, I mean.
Thank you, Peyton. B. Okay, I have a couple options. First off, intuitively, when you look at B, where are more x's? Top or bottom?
Bottom.
So when we simplify, there should still be more x's on the bottom. So because this is division, I should subtract the powers. What's 4 minus 20? Negative 16 again. Negative powers are bad, we move it down, and we get 1 over x to the 16th. How many had that right? Good. Alright, last little thing here. This one was a little different because I have coefficients, or just plain numbers. So there's a fraction there. 25 over 5. What's that?
5.
5. 25 divided by 5. Okay? And so that part gives me 5. What about the x to the 6th and x to the 8th? What do I do with those? X to the negative 2. Red flag, right? No negatives. So I got to move that down. So what gets moved? All of it? Is it 1 over 5x squared?
X squared.
The only thing that gets moved down is this. Okay, the 5 stays put. There's nothing wrong with the 5. The 5 is not, I mean, it's being multiplied by that. It seems like it's connected, but they're actually separate. It's multiplied by that. So the 5 stays put, it's fine. That x squared goes down, that negative 2 goes down, then it becomes positive. Okay? Any questions on those three? We have one more to do that you're going to see, a problem like you're going to see. Okay?
Zeros.
Oh, I do want to talk about that too.
That's an
Yep, I'm going to talk about that. I'm going to create another problem real fast. We'll do that. So let's make another problem. Let's say 8x squared all to the 0. All right, try those two problems. First off, whenever we do order of operations, what do you do first?
Whatever's in the parentheses.
Whatever's in the parentheses. So you better take care of the parentheses first. Okay, don't worry about the power on the outside yet. Okay, so what is in the parentheses? X to the 5th over x squared, what is that? X to the 3rd. So now that's simplified. Okay, now I have two problems left where I have a power raised to another power. And we haven't looked at one of those yet. You've done this before though. In fact, in Mr. Shooter's class, he probably talked about a little rule, how to remember it. Do you remember?
No, but I remember talking about it.
Powers in the sky. No?
Yeah, I do remember that.
Powers in the sky, you.
Multiply.
Very good.
I've never had this.
Oh, you never had Mr. Shooter. Okay. Well, so for example, let me explain why that works. Okay? Because that's often skipped. We make you learn rules and we don't tell you why it works. Okay? So here's a quick little example. A to the 3rd. No, let's do a to the 4th. A to the 4th to the 2nd. Okay? By the rule, powers in the sky you multiply, this equals a to the 8th. Okay? Now let me show you why. Okay? A to the 4th squared really means a to the 4th times a to the 4th. Right? That's what squaring is. Well, a to the 4th really means a times a times a times a. That's a to the 4th. Right? And then I have another a to the 4th. Which this is why power rules are so nice. Because it kind of doesn't, it's not great having to write all those a's out. But how many a's are there now?
8.
1, 2, 3, 4, 5, 6, 7, 8. So they invented exponents specifically so we don't have to write those all out. That is a to the 8th. That's why it works. Okay? In reality, what we're doing is we're multiplying, because anytime you raise something to a power, that's just as a shortcut of writing multiplying two things together, or three things together, or no things together, and we'll get to that in a second. Okay? So that's why when it's a power to a power, you multiply. Powers in the sky, you multiply. Okay? So go ahead and now finish up A and B, now that you know that. Okay? And I'll just leave that there, and we'll draw a little divider line. Do the rest of it over there. Okay? So my first move on A, when I go x to the 3rd to the negative 3, what am I going to get? X to the negative 9. Okay? Power to a power multiplier. And we have a problem, right? We don't like to have negative powers, so it needs to move where? Down. So this is 1 over x to the 9th. Okay? How many had that? Good. Alright, let's talk about b. And b is sort of a trick, and it has to do with this. Anything, this is the rule, anything, I don't care what's inside. Anything ever raised to a 0 power. You know what that equals?
0.
Incorrect.
1.
It equals 1. Okay?
All the time?
Here's why. Every time, anytime,
So the answer
every
is
time. The answer is 1. Anytime you have something raised to a 0 power, it's 1. And I know that your instinct is to want to say 0, and here's why it's not 0. Okay? Think about it in terms of multiplication, because that's what exponents are, right? Exponents are multiplying. It's a shortcut to write multiplying out. That's what all this is down here. Showing you how it's so much nicer to write x to the 8th than writing all the a's out. Right?
Yeah.
If anything to the 0 was 0 and I was multiplying by 0 a bunch of times, that's just going to knock things out. And all the values are going to go away. So what they did instead is they decided, okay, well, whenever you raise something to the 0 power, we're just going to make it 1 so that when we're multiply it by something else, it doesn't really affect anything. It doesn't affect values of other numbers. It's still okay, and it doesn't ruin another multiplication going on somewhere else or an addition going on somewhere else. So anytime you see something to a 0 power, it's 1. Now, one last thing I want to show you. Let's say I had a problem like this. I don't know why I have 7 stuck in my head today.
Wait, so is it 1? Just the answer's 1?
Answer's just 1. Let's look at this. 7x to the 0. Okay. This is different and not equal to that. Okay. On the right, the whole thing is raised to the 0 power. Okay? So that whole thing is 1. On the left, why isn't the whole thing raised to the 0? It's not in parentheses. So what is raised to the 0?
Just the x.
Just the x. Okay? So this part is the only thing raised to the 0, which means this part is 1. Okay? So this, again, is still 7 times. So 7 times 1 is 7. Okay? Be careful if there aren't parentheses there. Okay? Don't just assume that it's raised to the 0 power.